Welcome to your lesson on exponents. Here's our goals today. Today students will be able to understand the value of numbers using exponents and understand their usefulness. Students will be able to identify an exponent, base, and the different forms of an exponent. So let's go ahead and get started. First question is, what are exponents? Well, an exponent is a number that tells how many times the base is used as a factor. Now, that definition is a little tricky to understand, so let's break it down a little bit. 5 to the power of 3. This is an example of a number or a value written in exponential form. In this situation, 5 is our base. That's what we call the larger number. That's the number that's going to be a factor. 3 is the exponent. That's what we see as the little number up here in the corner. So what this looks like is we're going to take 5, the base, and that's going to become a factor 3 times because 3 is the exponent. So it's going to be 5 times 5 times 5. We can go ahead and multiply 5 times 5 on our calculator in our head and get 25 times 5 again, and our value is going to be 125. In this situation, there's 3 forms to this number. First is the exponential form, which is right here. Then we have it written in factor form, where we have the 5 as the factor 3 times. And then finally, our answer is what we call standard form that we'll take a look at later on. All right, so let's take another example. Here we're going to create kind of an exponent poster. So my example here is 4 to the third power. And I'm going to go ahead and label the different parts of my poster. If you're taking notes, you can go ahead and draw this example with me and label it as well. So in this situation, 3 is our exponent. The large number 4 is our base. Exponential form is this right here. It's the value written with a base and an exponent. So we're going to go ahead and draw an arrow right here. The factor form is when we write it in terms of our factors. So we would take our base of 4 and start with that. And then our exponent tells us how many times that's going to be a factor. So since our exponent is 3, we're going to have 4 be a factor 3 times. So this is what we call factor form, 4 times 4 times 4. And then standard form, again, is just kind of a fancy way of saying what our answer is going to be. So again, either on my calculator or in my head, I'm going to go ahead and do 4 times 4. Get my pen here. 4 times 4 is 16, and then 16 times 4 again is 64. So the standard form of this is going to be 64. Ways to read this exponent. One way would be 4 cubed. Anything to the power of 3 we say is cubed. And then also, the other way that I can read this, if I can get it to pop up here, there we go, is 4 to the third power is another way to say that. Power is just how we refer to exponents. All right, so let's go ahead and play around a little bit. There's some special rules when a base is to the power of 0 or when a base is to the power of 1. So what I'm going to do is use this calculator over here, and we're just going to try those out. So we're going to keep 0 as our exponent, and I want you to watch as I change the base here. Down here, you're going to see the standard form or the value. So 2 to the power of 0 you can see equals 1. 3 to the power of 0 also equals 1. 4, 5, 6. You can see that no matter what the base is, as long as the exponent is 0, it's always going to be equal to 1. So we can go ahead and establish a rule that any base to the power of 0 always equals 1. A lot of people think it's going to be 0, so it's a little counterintuitive to what you might have guessed. All right, how about if our base is 1? So we're going to go ahead and change this to 1. I'm sorry, if our exponent is 1, we're going to change our exponent to 1 and then play around with the base here and see if we can come up with a rule for this as well. So 10 to the power of 1, you can see the answer in our standard form is 10. How about 9 to the power of 1? Our answer is 9. 8 to the power of 1 equals 8. Let's get it really high, see what happens. 21 to the power of 1 is 21. Did you notice a pattern? I can see that any time I take an exponent or a base to the power of 1, it seems to always equal whatever the base is. So we can go ahead and make a rule for that as well. Any base to the power of 1 equals whatever the base is. So go ahead and jot that down if you are taking notes too. These are two really important rules to remember. So again, any base to the power of 0 always equals 1, and a base to the power of 1 always equals the base. All right, let's go ahead and try a few here. We're going to solve these expressions, put them through our tunnel, and take a look at them in factor form and also in standard form. You can see right now they are in what form? That's right, exponential form. Oh, sorry, we'll get rid of that. All right, so we're going to take the 3 to the power of 3 and see what that looks like. There's our factor form, 3 times 3 times 3. 3 was our base, and 3 was also our exponent, so we're going to have 3 be a factor 3 times. Then when we multiply that out, we get our standard form of 27. All right, just think for a second what 4 to the power of 2 would look like. And we'll put it through our tunnel. Since 4 was the base, that's our factor, and 2 is the exponent, so we're going to multiply by itself 2 times. Our standard form, we can go ahead and calculate 4 times 4 is 16. And then lastly, 2 to the power of 4. We'll go ahead and put through our tunnel. And 2 was our base, so that is our factor here. And the exponent was 4, so we're going to do 2 times itself 4 times, equaling our standard form of 16. All right, let's do one more set of problems, looking at it the other way this time. Now you have the factor form, 6 times 6 times 6 times 6. So think for a second, what do you think that's going to look like? And let's go ahead and reveal it and see if you're right. Since 6 was our factor, that 6 is also our base. Since 6 was a factor 4 times, you can see that our exponent is 4. Now if we calculate this on our calculator, this is going to get to be a pretty large number. We would get an answer of 1,296. All right, problem 5, we have 7 is our factor. So I think 7 is going to be the base, and then I'm going to count 1, 2, 3, 4, 5. 7 is a factor 5 times, so our exponent I think is going to be 5. Let's take a look. Sure enough. So we have 7 to the power of 5. 7 is our base 5 times. Again, our number is going to get pretty huge here. So we can go ahead and do that on our calculator. We'll get 16,807. Number 6, we have 11 times 11. So you can see that our base is 11. And it's multiplied by itself 2 times, so 11 to the power of 2. We can go ahead and multiply that out and get a value of 121. So that concludes our lesson on exponents. You're going to have 2 activities coming up. I'll just show you those really quick. This is the first one that you'll be doing a little bit later in your lesson on exponents. On this sheet, you're simply going to look at each exponential form, write that down in factor form. Again, just remember that you are taking whatever the base is going to be your factor, and then your exponent's just going to tell you how many times. Then once you've done that, you can go ahead and do the standard form. Use your calculator if you need to, and write down the answer. Your second activity looks like this. Again, you're going to look at exponential form, factor form, standard form. Now we're going to add word form. So it's going to be a little bit of a matching. It's going to give you a different form for each one, and you're going to be filling in the blanks. So for this first one, I see 2 times 2 times 2 times 2. So I'm going to look for my exponential form where 2 is the base and it happens 4 times. So I would put this right here. Standard form, if I multiply that out, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm going to put that answer right here. And then word form, I'm going to say this as 2 to the power of 4, or 2 to the 4th power, which is right here. So those will be your 2 activities today, as well as some computer practice. So good luck.